Assalamualaikum. A very good afternoon to all of you. Welcome to INBIOSIS webinar lecture series 4 in the year of 2023. I'm Bazli. I'm your moderator for today's webinar. The video that we played just now captures the gist background of our institute, the Institute of System Biology INBIOSIS, located in University Kebangsaan Malaysia, UKM, Bangi, Selangor. For those who have not seen the video or never been to INBIOSIS, I hope it has given you sufficient insight on the institute as a whole. So for those who are interested to collaborate with us, you are most welcome to do so. And also feel free to browse INBIOSIS website and social media for the latest updates and info. All right. I feel so grateful today that all of us are granted good health and time to attend this webinar. This is our fourth webinar for this year, and we are glad to have our honorable speaker for today, Dr. Muhammad Azinuddin from FGV. Before we start, allow me to share with you Dr. Azinuddin's CV. Dr. Muhammad Azinuddin Ahmad Mokhtar is a molecular biologist by training with over 15 years of experience in plant molecular biology. Dr. Azinuddin holds a PhD in biology for the University of Leeds, UK. He has worked with several R&D companies, including Apical Scientific and, of course, FGV, in various roles, including technical support officer, researcher, senior researcher, and lead officer, and currently the head of the genomic unit. His key achievements include successfully leading development of SSR Markers services, DNA profiling of all plant collection, and digitalization of breeding data that lead to winning 2 silver medals during ITEX. So for those who are not familiar with ITEX is one of the prestigious exhibition in Malaysia, research and development exhibition in Malaysia. And currently, Dr. Azinuddin is the lead researcher at the plant breeding unit of FGV. Okay, without further ado, let us welcome Dr. Azinuddin to share his experience with us. All right, Dr. Azinuddin, the screen is yours. Thank you.
Thank you, Dr. Bazli. Let me share my slide. Okay, Assalamualaikum and good afternoon. As Dr. Bazli said, I'm Muhammad Azinuddin by Mokhtar. So basically, INBIOSIS is not it's not new for me. INBIOSIS is my first where I did my master, and I'm Dr. or Prof. Ain first postgrad student. So back in 2017, yes. So for today's presentation, as you have read the abstract, so my topic will be application of molecular biology tools for the development of new oil palm varieties. So before I start on focusing on the research itself, let me introduce LGV first. So FGV, this is a picture of Wisma LGV located at Jalan Raja Laut, KL. So basically, this is all of LGV products. You might have eat it, you might use it. So I believe most of us use cooking oil from saji and the gula prai or the sugar. And we are also producing fertilizer and also feed products for animals and bio fertilizer. So for topic today, we focus on this related to these two products, Yangambi ML161 and Yangambi 3-way. It's a two product. It's a variety for oil palm that we commercialize for Malaysia and international markets. So a little bit on the FGV or FELDA. FGV is actually come from FELDA. So we are established in 1956 when the Ordinance of the Land Development was established. And then I believe all of us know that the purpose of FELDA is to help the poor, to uplift the lifestyle of poor peoples, and then to have these people ownership of the land. And then from there, we grew into Felda Holdings, a commercial arm for Felda, and then incorporated of FGV. And at that time, our name is FGV as a Felda Global Ventures in the bracket as FGV. And then the MSM company that we bought previously, we listing into the stock market. Then listing of FGV in stock market in 2012. Okay, FGV is a company focusing on oil palm, and it's covered the whole supply chain. Well, I mean the whole supply chain is covered from the starting of the materials, the seed itself, the planting material, until the extraction of the oil. So it's a big company. So for my topic today, we're focusing on the R&D. So our land area, our land bank is more than 300,000 hectare that cover oil palm about 336 hectare and rubber. And then we also have sugar through MSM company with capacity operation of 2 million metric tons. And then we have logistic and others. Logistic is, if you notice, you will saw a lot of tanker in the highway. That's another subsidiary of LGV, focusing on delivering the oil, the CPO, to the ports from the mill or to the refineries. So our capacity in storage of this vegetable oil is up to nearly 1 million metric tons. And we also have another one with so-called integrated farming. The main focus of integrated farming is to explore different type of crops, such as pineapples, bamboo, cassava. So most of this planted area is located at Chuping Place. So my focus is just for R&D here. Basically, we have 3 stations for the research station, Pusat Pendidikan Pertanian Tun Razak, or located at Jerantuk Pahang, which is where I'm at now. And the other 2 is a LGB Innovation Center at Bandar Enstad Negeri Sembilan. And we have another at Sahabat as a research center as well. So beside these 3 main research centers, we also have another 18 small research centers. Is depending on the type of the projects. So I give you an example. We want to find a plant variety that is tolerant to drought. So we need to find an area with drought condition, drought environment, low rainfall. So we set up a station at Chuping Place for this purpose. Because of this trial, then we have a station there. That's just example. And then this clonal production center is at Bandar Enstad, and 3 fertilizer plants. I will explain this furthermore later. So this is the objective of R&D division in FGV, to be leader in creating value for agribusiness through R&D. So in R&D division, we have 3 companies. You might confuse FGV as a service company. So we have another subsidiaries. Basically, that's how most of the corporate works. We have small companies too easy to manage. So within R&D division, we have 3 companies. The first one is FGV R&D Berhad, and this is why I'm employed. And then we have LGB Agri Services and LGB Fertilizer. Basically, the difference between these 3 companies is that LGB R&D is responsible to develop new products, the new plant varieties, new biofertilizer, new formulation for margarines, oil. So it's all under this company. And then the FGV Agri Services is for commercialize. The reason why there are 2 companies focusing on this because of the double tax deduction from the incentive given by the government. And then fertilizer, of course, fertilizer is to process, to produce, and then to deliver the fertilizer. And it's also belong to R&D division because there are improvement that be made through R&D, either by using biofertilizer or the improvement of the production itself. So for our research partners, these are our research partners cover from local and internationals, and these are our customers. So this is what I'm saying before. We have 18 research stations. The main one is in the red, Tekam, Bandar Sahabat, and Bandar Instek. The other research station is based on trial. Either it's for drought, for the diseases, or for the fertilizer formulation, new fertilizer formulations. So a little bit on the stations. Pusat Pendidikan Pertanian Tun Razak had been established in 1968 by the late Tun Razak, our Prime Minister. And the establishment of this station is basically to focusing on the new plant varieties. That was the mandate given by government through FELDA previously. They give us 12,000 hectares to find to improve the plant varieties for smallholders or the peneroka settlers. And then beside plant breeding, we also have seed productions. Once we have the plant variety, we produce seeds and then to send to the customer. We also have beds, agronomy, crop protections, cash crops, and other strategy crops. And also through we also did research on mechanization and mill improvements. So these two is basically the same place but different compound. So this one is based on is a LGB Innovation Center biotechnology, focusing on the tissue culture productions. So I have a slide and one. So and then the other complex is focusing on beneficial microbes, and the next one is food technology. So beneficial microbe is identifying new microbes to be used for fertilizer or to be used for in the mill improvement or in any processes in LGB. And also the food tech, as I mentioned, for the developing a new product, either the oil, the saji, the margarine, the butter, the spread. And for this Sahabat station we established, basically it's about the same as a Pusat Pendidikan Pertanian Tun Razak, just is smaller because of the reason why we established, because Sahabat or Sabah area is different, the environment, the soil is different. At there they more on coral soil, so the treatment is different. So we want to do a trial there, and then the diseases, the infection rate is different there. Like Ganoderma infection is quite high there. So this is the layout of the LGB Innovation Center. The whole building here is a biotechnology for the tissue culture, where tissue culture production with productivity, with capacity of producing 2 million ramets a year. And then we also have building or blocks for genomics and tissue culture research. And the next building, like I mentioned, for beneficial microbe and food technology. So the R&D, there are two companies located at Bandar Instek. The LGB R&D is the research area, but LGBAS Agri Services commercialize the kernel products and biofertilizer. They also biofertilizer productions. You notice that LGBAS and LGB R&D always together because most of the thing need to be work together because of if I give you an example here, kernel lab, there always be issue like why the calyx cannot be germinated. So people from R&D will come and advise. If we are in the same complex, then just go. Easier for the transformation, easier for the communications. Yeah, a little bit on overview for the tissue culture research. Basically, I will not read everything, so I will brief on the slide. Basically, the reason why we focus on tissue culture to replicate high yield palms in the field. As you know, when we do breeding, normal crossing, we will not get the whole progeny. Example, if we have 10 progeny, we not get the whole 10 perform uh, like one, the higher performer. Some of them will be higher, some will be lower. So we want to clone the higher performer, then we will be able to replicate faster in terms of number of pump in the field, so that we can increase the number of yield in the field per hectare, and we also can make the utilization of the land better. Beside cloning a palm, we're also focusing on the other crops. Like here, banana, pineapple, bamboo, vanilla, cassava, and coconut. So even though this palm is actually available through the normal crossing, but then the production is not enough. Our market need more. So that's why we focusing on this cash crop through cloning, so that we can have we can mass production of the planting materials. So for genomic research, genomic department was established because they want to help breeding, planting material production, and also tissue culture research. So they help through the developing of DNA markers for planting material productions, and also for developing a marker for assisted breeding, for help in production of new planting material. Sorry, there's typo there. And then by using this marker, we can also ensure that high quality planting material will produce. And then for sustainable of high yielding planting material with the ability to withstand environment, stress, and diseases. Because of, when the, like I mentioned before, only single or only in the 10th example, only one pump might be higher in the of yield. So the same will happen for the diseases. So might be only one pump is have tolerant to disease. So but how are we going to identify? So this is where the marker chip in. And then geoinformatic research to develop and using the advanced geospatial and precision technology. This picture here is a geotagger, and another product that been developed by LGB R&D that win gold during the ITEC this year. So basically, this is a device that help to precisely pinpoint the location for the pump to be planted. In the oil pump industry, most important, sorry, in the oil pump plantation, the most important thing is the density, the number of pump, the number of pump stand in the hectare. So we need to have a correct and precise number of pumps, so that we will fully optimize the land usage. So by using this, we develop it through collaboration with MMU, and then it helped us in identifying specific location to be planted, and then it helped us to maintain the number of stand in the in the plantations. It can give us the precise locations to the planters to plant the palms. And then another research is focused on biosolution and renewable energy. So biosolution is to identify a microbe that help us to produce new biofertilizer. It's either to combating the ganoderma diseases or any other disease, and also to improve the plant growth. For the renewable energy, where we use a microbe to help reduce the BOD level in pome discharge is a discharge from the mill. The water discharge from the mill to comply with DOE, Department of Environment requirement. It must be BOD 20. If not, all the meal will be the meal can be soup. So we use microbes to reduce this. And besides, you also use microbe to shorten the composting period for the EFB, empty fruit bunch. The other department is focusing on food-based research, where all the product that being sold right now in the market is actually come from the research in the LGB under food tech research, where they develop the cooking oil under different type of can or the packagings, and also different. If you notice, most of in the market, most of us will buy saji. They also Adela for the is a blended oil that have different taste, a little bit taste, and then margarines, shortenings, all these have been undergo R&D for developing the formulations. And then for the non-food, like Alma that I showed previously, the products that LGB produced. So these come from the R&D from this department, where we use waste from the plantation and then create formulation and use it to the for as a feed to the dairies, and also biochemical and chemical research on identifying the fibers from the EIB can be used for others products, and also the bioethanol. Yeah, it's from all from this is focusing on the wealth, from the waste to wealth. So now we go for my talks. So my talk will be focusing on molecular biology tools for developing this, how we control, how we utilize molecular tools in developing these two plant varieties in INBIOSIS 1 and 3 ways. So a little bit on the background. So all palm crop is there are two species for all palm, Elis genesis and Elis oleifera. They are tropical perennial crops and what we consume in the form of vegetable oil. So generally, all palm, of course, I'm from LGB, so I will promote all palm, but basically this is about facts. So all palm is the most productive oil, vegetable oil in the world. Why I'm saying that? Why I'm saying that? Because of it need 10% of land lesser than other crops in order to produce 35% of oil in the world. They call it demand 35% of world oil demand in the world. This is another picture to compare. This is the land size for oil palm. And then this is the land size for soybean. The same in order for producing 1 ton. Again, because of this new productive, I'm not sure why. Maybe because of the economic purposes, the politics. So it make all palm the most hated crop in the world because of it cheaper and it's productive. Another reason why it's been hated because of this. If we go through our daily use, you might not notice before. If you really thorough about detail of your products that we use, you might aware that as all palm in almost all the products, starting from the morning, from the soap that we use, the toothpaste, and then if let's say you have cats, the animal feeds, and during the lunch, during dinner, most of this have a product in all palms. Okay, on the plant breeding side, since 1916, where the plant breeding started, and then in 1980s we start to introduce our plant varieties. In 1980s we marketed a product so-called as Lame, Everos, and Yangabi. This is different background of palm. Example, if we know durian right now, durian have different varieties like IOI, D24, Musang. So that is a different varieties. Same goes as all palm. We have different background, but the name is different. The name is according to the place or according to the station that being produced, not produced, being identified. Like Lame is a place in Africa, Avaros is research stations, and Yangambi is a place in Africa. And then in 1990s, from the research that we used, in 1990s, we focused on Yangambi. And then in 2000, we focusing on reproducing Yangambi ML161. And then 2010, we producing Yangambi three-way. It's a three different background, Delhi, Nigerian, and also Yangambi. And in future plan, basically in 2020 to up to forward, we want to focusing on the environmental stress. Right now we know the climate change. We want to focusing on drought tolerant. Even in Malaysia, we so-called as climate change, we is synonym with the dry. But again, more area being flooded. So we also want to focus on the planting material that can tolerate to being submerged underwater at the flooded area. And also, of course, the diseases. From all this research, we have shown that the performance is increased, like from the first materials, the Lame, Avaros, and Yangambi, the oil performance OG been producing is 6.31 per hectare, and then increased to the 7.39 and 8.43, and then up to 9 for the three-way. So from the first material being commercialized up to the latest one, three-way, it have increased about 44%. So a little bit on oil palm breedings. So oil palm breeding is this will be, I will present about the conventional method, conventional oil palm breeding. Oil palm breeding is a method where it take a longer time, it take a long time, up to 10 years. So example here, we have D times D trial, Dura trial, and then okay, in commercial we use Tenera pumps that is D times T. So in order for us to have to select the Dura pump, we need to conduct trial on Dura side, and then we also need to conduct trial on Tenera side. Why Tenera? Because of we cannot do P times P, Piscifera times Piscifera, because Piscifera is a abortive plant. It will not. So we use Piscifera as a pollen source, as a father pump, and then we cross with Dura side as mother. Then we need to evaluate from the selfing or seed to ensure that the pump itself is being certified past the CRIM standard. For all seed producer, all palm seed producer in Malaysia, we need to comply with MS 157 2017. It's a requirement for mother and father pump before it can be used for commercialized in order to produce the seed productions. So beside the D times D and Tenera trials, we also do this progeny test in the middle. Why we do this? Because this is the DP that when being commercialized. We need to ensure that the combining ability between this Dura and Tenera, Dura and Piscifera. Because we know sometimes if we cross with different pump, example, we have Dura A and Piscifera A producing the Tenera. For this combination is okay, but maybe Dura A and Piscifera B, and then the Tenera is not performed. So the combining ability of these two need to be tested before we can use this line or this pump to be commercialized. This is just an example for one cycles. So this is the years, the trial period for each crossing. So one cross, we need to have at least 7 years year recording. Normally for breeding, we record for 10 years, but 7 years is the minimum because of these parameters here. Okay, these are the 3 main activities that we use for palm breeding. We need to have data for 4 years, consecutive years. four consecutive years, meaning that if let's say they are during this period, example 1, 2, 3 years is fine, and year 4 suddenly El Nino is coming, or there is a shortage of fertilizer, so we cannot use the year 4. What will happen? The whole 4 years we cannot use, so we need to have another 4 years. So that's the reason, the main reason why all palm breeding trial is take long time. And then bunch analysis, meaning that all the bunches that be produced need to be tested in the lab for the oil content. So at least 30 bunches per progeny need to be used for this analysis to ensure that before we can say that this progeny have this kind of performance. And then the vegetative measurements, this is more for the agronomic traits like dwarf palm, shorter frond. So in the requirement, we need to we can measure this palm during 8 years. The most optimum age to measure the vegetative is 8 years, at year 8 of the planting, after planting. So if we want to select for the vegetative, we need to wait for at least 8 years. So this is the main reason why it takes longer. It's the process itself, not the technicality of it. Okay, then how you produce this palm? There are two methods of producing palm, all palm seed or palm progeny. Either is to control pollination or cloning. So control pollination, this is the process of control pollination. The upper line is a process for father palm or the pollen source. So the workers need to climb the palm using stairs and then find the pollen and need to harvest the pollen, sorry, and then prepare the pollen and then check for the viability. Viability means the ability of the pollen to germinate or to producing a pollen tube. And then for the mother side, you also need to bag the flower and then use the pollen from here to pollinate the flower and then harvest. Okay, all this process is takes time. It's about all this process about 1 year. And then once we have the bunch, then we need to undergo all this process in order to get the seeds. So this is another 6 to 7 months to get this. So imagine like more about almost 2 years to get seeds. But for cloning, we need to identify a palm that is higher performer, and then for us to identify a higher performer palm, you need to undergo the process that I mentioned before. We have to 4 consecutive years of data, and then 30 bunches of batch analysis. And then if you want to select for vegetative traits, then need to measure at year 8. So even though by cloning, we so-called as a fast method, it also need to wait for that data to be completed. Then we can use that palm for cloning. However, even though cloning is quite fast, not for all palm. It will take 2 to 4 years for us to producing aromats. These are the process for laboratory process for producing the clones. Okay, why it's important for us to do a quality control to ensure that all the party material we produce as what you claim, because we want to ensure high oil productions, ensure the heritability of the specific traits, and to ensure that the product, reliable product being produced. Yeah, this you will understand later. You see, okay, as I mentioned before, the tenera have been used for the planters. So it must be come from Dura and Piscifera. This is basically the Mendel inheritance law. So when DD and PP, pure D and pure P is crossed, we get tenera. The difference between these three fruit type because of is the shell. If you notice here, the shell is quite this thin, is thick, and then there is no shell. And then the oil is coming from this yellow ring here. It's a mesocarp. Okay, but we cannot use Piscifera. Of course, from the look here, why not we use Piscifera, right? Because Piscifera have more mesocarp. But again, because of the Piscifera is normally abortive, that's why you use Piscifera as the pollen and then cross with Dura to get Tenera. And that's why we focus on Tenera, because Tenera is have 30% higher oil yield compared to Dura. Previously Dura was planted as a commercial in late 1960s, 1916, and then when they find their potential for Dura and this crossing of Dura and Piscifera producing a Tenera higher yielding, and then all the plantation are focusing on the Tenera. So the conventional way, okay, this one is for to know the food type. So after 3 to 4 years from the starting of control pollination until planting at the field, then we know we will only know that the palm is Tenera or Dura. While we're using D&D tools, we can know it's early since in the nursery itself we can do selection, or perhaps during the if for cloning, during the tissue culture process we know it is a Tenera. So okay, for Dura and Piscifera, we want to check for the Tenera is quite simple. It's just from a single gene known as a Medbox genes. Be published by MPOB previously. Also, the gene renamed as the shell genes, and then there are 10 mutations on that gene. We just develop marker based on that 10 mutations to find whether they are Dura or Tenera or Piscifera. So basically, for the Tenera, is combination is heterozygote from these two mutations. The mutation at the Piscifera, the Dura, there is no mutation. So if we find a mutation at one strand, it will be producing a Tenera. But how about if there are multiple Piscifera? It's still producing a Tenera, right? Like I mentioned before, if we have another Piscifera, it's still producing a Tenera, but it's not performed. How are we going to know? That's why we implement this one, legitimacy test. It's based on the SSR marker. So that we need to do profile for the mother side, and then profiling the father side, and then do a profile for the progenies, and then mesh back to ensure that the progeny is belong to the correct cross. It could be come from the other crossing, or the crossing that is not being control pollination, or there is contamination during the control pollination. So we need to ensure that all the seed being produced is come from the correct parent. That's the important of. That's why we need to do litmus test to ensure it's come from the correct parent, and then that we know the performance. Okay, this is what I mentioned before. It's been published by POB using shell gene. There are 10 mutations. That the 10 mutations come from different background. So this marker been routinely used by the seed production unit in FGB to detect only Tenera seedling that been used, be commercialized. This is the I mentioned about the SSR markers. We also name as a DNA fingerprinting. So in LGB, we identify SSR marker that been produced, been published previously by our collaborators in Sierra, France. So and then we use that marker, and then we also use marker from MBOB itself. Then we try to optimize them the markers. Now we use up to 30 markers for legitimacy, and then we also did optimization by using instead of single plex, we now using multiplex to ensure our higher productivity in screening the palms. So this is basically the process. I believe all of you are aware of this because the INBIOSIS video is start from DNA, right? So just very I could call like a school quiz lah. Okay, this is a victim. This is a crime scene, blood on the knife. So which one is the suspect? So this one suspect 2, and then also this one, the mother, child, and which one is which is the potential death. So that 3. So this kind of this is just analogy, but this is the thing that we do in LGB. We find the parent, which one is the parent, which one is the original palm for the cloning, right? So this is an example of how it look like in the actual data. So the father and mother, and then this is a progeny. This is a single marker example. So the father profile is like this, mother profile is like this. So the progeny profile will carry one of from each, like the father following the Mendel law. So this is profile from the mother, this one, and this profile from allele from the father. Same goes here. Yep. And for the cloning, the OTAP means the original pump, the single pump that we identify as a high performer that we clone. So cloning is just like a photocopy machine, so all have the same profile. Again, this is not always true. You know that in cloning there are some clonal variations. We have issues in like out of nowhere, some of the allele is missing. So we need what we did that we based on the history that we know this is a clonal. So there are certain criteria for the selection based on if the profile come from the clonal. So for conventional breedings, okay, if let's say we want to incorporate a single traits. Example like here, this palm have a stress resistant, but they are poor in agronomics. Agronomics means that the performance or the physical palm is not plantable. They have abnormal, like the leaf is not poor, not have a poor development, right? So we have another palm, stress sensitive, but they are good agronomics. So how are we going to integrate this? By using crossing. So normal crossing, if you notice the number here, red belongs to the stress resistant, green belongs to the good agronomics, right? We need to have at least 5 to 7 cycles of back crossing to get the palm with stress resistant and good agronomics. This is 5 to 7 cycles to imagine all palm. One cycle 10 years. Again, even though it's took longer time, it's cheaper. However, it have more land to be tested. To test several crossing and several cycle of cross. Instead of rely on conventional, we incorporating the molecular breeding process. Beside the shell and the legitimacy test, which is a routine test for each of the crossing. Like example here, if let's say we cross between A and B, we need to ensure that the progeny is a correct progeny and have a shell or the fruit type that we want. Beside that, we also do molecular breeding to identify uh, uh, to incorporate different traits. Like for other traits, it's much complex than the shell. The shell is based on single gene, but the legitimacy is SSR marker that have distribute throughout the genome. While for the molecular breeding, is based on the traits like disease tolerance, or perhaps the dwarf. So it involves multiple genes. It's a complex process. We need to do a whole genome sequencing, and then marker mining and genotyping, and then after that, do a genetic mapping, trait associated marker with, and then do a GWAS or genome select in order for us to find the palm. Once we have all this so-called lab data, then we need to validate at the field. Then we need to do field trial validations. And now I would say in LGB we have several traits and still in the lab process, but in the conventional way, most of the palm are already planted. Just we need to plant breeder need to pick which progeny that has stable traits. Like here, the palm has a stable trait that incorporate both trait that breeder want. So these are the traits that have in our palm. High yielding, dwarf is coming from different species, and oil quality is coming from different species. So these two basically come from the Genesis olifera, sorry, Elas olifera, and then Ganoderma resistant is very hard to find. Now Ganoderma is had been identified so long ago, like more than 30 years, I guess. But until now, there is no planting material that's suitable to combating this disease. Compact palm variation is different color of the fruits. Instead of in all palm, instead of the black, from the black turn to orange, from the green turn to orange. It's more for the identification, so that it is the harvester to find which bunches that are derived, and drought tolerant, resistant to pests, efficient nutrient uptakes. This all comes because of the fertilizer. Fertilizer cost now is double due to since the PKP, the price is double because of the transportation issue, and then the war in the Russia there make the situation worse. And then abnormal free clones. Is it possible? This is just the aim in the plant breeding. Is it possible to incorporate all these traits into a single palm in order for us to producing a super elite palm? That's just like the idea. Okay, the other trait, I will pick just one trait, Ganoderma tolerance. So Ganoderma is a white rot fungus that grow in at the basal stem of the palm. It look like this. So what happens is that in all palm industry, normally we do a replanting after 20 to 25 years. Because of this infection of Ganoderma, we have the palm will be fallen by 10 before 20 to 25 years. But then if there is a replanting now in Malaysia, they get the issue is getting worse. Because of the way that Ganoderma infecting the palm, they grow on the root itself. So in the next generation of replanting, it will the infection rate will be higher, perhaps during 2 or 3 years of replanting after planting, the infection, the Ganoderma is already present there. So it shortened the age, the economic age of the palm itself. So in as I mentioned and from the beginning, in the plantation, the important is the number of stand. If the number of stand palm in the field is lesser, then it affect the number of oil being produced from per hectares. So we will present this poster in PPOT 2023 during November. So basically, the idea of this using CRISPR is to identify potential gene first. Then once we identify potential gene that actually cause the infection in the oil palm, and then we try to identify the gene that work together, or the effect, the component in the palm that work in this with these genes. Then perhaps we can use these genes to alter the genes, or using CRISPR to edit the genes. Then we can have a so-called tolerant or resistant palm, because of there is no more gene in this palm. That's the idea. But again, still in the progress, we managed to edit a gene in the ganoderma, and then the next step is to find that gene. We already have the gene list. Need to do a proof that need to edit the gene, and then prove it whether it cannot, and then whether we can produce a strain that cannot infect in the oil palm. So I will play a video. Let's see, this video is available in at YouTube. In a second. Sorry. So I can play from there. So
these are Dura fruits.
Can you hear the sound?
Yes, yes.
They have thick shell and thin mesocarp. These are Dura fruits. They have thick shell and thin mesocarp. These are Piscifera fruits. They have no shell and thick mesocarp. These are Tenera fruits. They have thin shell, thick mesocarp, and produce more oil. But how can we get Tenera palms? When Dura palm is crossed with Piscifera, we will get Tenera palm. Dura mother gives a thick shell gene. Meanwhile, Piscifera father gives a no shell gene. The progeny will inherit 50% gene from each parent. This progeny will produce fruits with a thin shell. They are called Tenera palms. Now, how to ensure that we cross them correctly? We provide legitimacy tests to screen the seeds produced. You can contact us for more information. Ini adalah proses memprofil DNA. Sampel yang diterima diproses. Sampel tersebut akan dihancurkan menggunakan mesin tissue laser. DNA daripada sampel kemudiannya diekstrak. Kemudian DNA dimasukkan ke dalam gel. Gel DNA dilihat dengan menggunakan mesin UV tag. Ini adalah contoh keputusan kualiti DNA. Jumlah DNA kemudiannya dibaca. Seterusnya, DNA dilarut menggunakan mesin. Bahagian DNA digandakan dengan menggunakan mesin PCR. Setelah digandakan, DNA dimasukkan ke dalam mesin analisa. Dengan itu, profil DNA dijana.
Okay, so I continue. The open genome have been sequenced by MPOV previously. So they identify 3 genes: the shell genes and the virusin genes for the colors, and then the def one. Def one is for abnormality for the clonals. And then we also they are still research on focus to find other traits. So because of the genome itself is complex. So these virusin genes based on mutations at the MYB genes transcript factors, and karma based on the epigenetics changes at the karma transposable elements. And then this to share that other companies also use also publish open genome map. Then and then they use the map to find markers for various traits. Let to end my presentation. So basically, for the conclusion, open tool is important for open breedings program, and also for commercial production, as it acts as early quality control and guide in selection of open material, and also it's help in expediting the open breeding program itself. With that, thank you.
Okay, thank you so much, Dr. Azinuddin. Such an insightful talk by our industry expert. So yeah, I will read questions from the chat box, but before that, I have my own questions. So the three-way variety is derived from clonal or pollination?
It comes from the control pollinations. The three-way, why we name it as three-way, because of 3 background. Normally for plantation we use D times P, daily Dura with Piscifera, and then normally beside that the background is normally just 2, but ours is different. Delhi times Nigerian times Yangami.
Okay, thank you. So the three-way variant is not yet resistant to Gardnerella infection, is it? Or maybe there's a percentage in terms of the infection rate occurred in the fields? Do you know any?
The three-way is not, but I cannot say the whole three-way, because the three-way is come from the various progeny. Some of the progeny have, some of the progeny not, but we lump we pull it together and sell it as a three-way.
Right. Okay. Thank you. I got a question from Dr. Nisha Govender. In open breeding, what is the experimental scale employed for the progeny test? For example, number of plants, and extent of reproducible results across different geographical regions?
Okay, in a single cross, normally we use 3 times 3 plots, and then times 3 for the replicates. So normally for single cross, we planted about 64 plants. And then for the different location trial, as I mentioned, we have different stations. So we will send this seedling to a different station so that we can plant there to evaluate and then compare between these two geographical locations performance. Yeah.
Okay, thank you so much. Another question. May I know what are the breeding methods being used in FGV?
We use the normal method for breeding. We can use NCM1, NCM2, or incomplete NCM2, depending on the which strategy that you want, or the which kind of operation or the data to be collected. If there is a NCM1 is more easier, but have a different setback. But NCM2 is have different advantage. So depending on which strategy, which trait, or which kind of whether you can get the data actually. So since like as I mentioned, it's 64 fun. So can you ensure that you get the whole for the complete crossing for the NCM2 or NCM1 example?
I got another question. This is same question like mine. You shared a slide on the super elite variety. Although you've already mentioned that it is almost impossible to get all these beneficial traits in one plant, but what is the ideal trait that you think that will be the ones that you're looking into?
Okay, of course, when FGV producing a seed, what we want to have a customer buying the seed. So we need to understand what customer want. For FGV, for customer, of course they look for yield. Like for the settlers, they want the the bigger or bunches that is heavy, so that they can earn more money when they send the bunches to the mill. So that's one. Of course, breeding will always focusing on improving the yield, and then we come up with the other traits. We know now the disease, granuloma disease, is becoming serious. So of course, we need to have a material that have high yielding and also the granuloma. That's combination of two. And then we also during the PKP, during the MCO, we open industry facing labor shortage because of the labor already in Malaysia can return back to their home country, but they cannot come to Malaysia to work. So we try to improve in terms of mechanization. So in one of the trait that already have in the oil palm is a long stalk. Long stalk is the tangkai panjang. So we can use this variety to help in mechanization. If you watch video in YouTube, they are drone using laser to cut it. So perhaps we can use that. But again, is it high yielding? Biology, once the energy come to this certain area, there will be energy lesser in this certain area. Like now, we want to focus on long stalk. So how about the yield? The variety that we have now, the long stalk, but the yield is lower. So there must be a balance between these two traits.
Right, thank you. So that question is from Shamuddin on Facebook. So I got another question from Alia Natasha. So echo Dr. Azinuddin. The question is about granuloma. What are the preventive measures to ensure the plant is free from granuloma infection?
Okay. Normally in FGV plantation, before replanting, we will do granuloma census, and then we will identify which plantation have certain percentage of granuloma. In our practice, more than 20% will do complete sanitizations. Sanitization means that we need to know the palm where we planted the area that we planted with the palm. We need to dig out all the soil and then put on the surface so that the soil will be exposed to the lights. So then we can be kill it can kill the mycelium. That is one thing, and then beside we call as deballing. I mean, we take the whole the soil then put and then put on the surface, and then the soil we replace with other soil, so called as clean soil from different places, put there, and then beside that we also do liming to adjust the pH, and then do apply certain products like trichoderma products like we have by pharma shields, so to prolong the to no to kill the mycelium and then to prolong the age of the palm. This is just a preventive measurements after the ganoderma is already there, and then we want to plant new one. The palm itself, there is no palm that is tolerant to ganoderma.
So even in other countries like Indonesia, they face the same issue, is it?
Yes. Indonesia has also ganoderma. They also claim that this from my talk with NPOB, they claim they have a ganoderma tolerant materials. But then when NPOB got the materials tested here, it's not tolerant. It's not we not question their results. The issue is might be because of, as you Ahmad, Dr. Bazli know, ganoderma has different strain, different location, have different aggressiveness of the ganoderma. So perhaps their Indonesian strain is different with Malaysia, maybe because of that.
All right, thank you. Another question, if you don't mind, what are the
Sure.
challenges in conducting molecular breeding in oil palm?
Okay. I might not explain the last slide, the SINDABI one. The SINDABI, if you notice, they start launching their genome project back in 2001, if I'm not mistaken. So they just launched their product in last year. So it's about 20 years of research in molecular breeding. So it started from the sequencing the whole genome and then finding a suitable algorithm to fish out to do a GWAS, to do molecular breeding. So that's the biggest challenge. And then beside that, as I mentioned in the earlier, molecular breeding is also part of the conventional breeding. We need to wait for a certain number of years. If our molecular selection is based on agronomic traits, we need to wait at least 8 years for selections to confirm or the marker can be used for this traits. So the time is a issue because we need to comply with all these requirements. Other than that, I would say the expertise. Not many people experience or expert in molecular breeding, even though we have a lot of universities teaching, but the actual when we want to apply is totally different. And what like SINDABI itself, what they did, they have a consultation from overseas, and then the same goes with LGB. And then what LGB also did is that we consult the NPOB.
All right, thank you. I think last question from me. You've discussed about the current work on genome editing in Ganoderma. So what is your take on the CRISPR-Cas based genome editing for the pathogen as well as in oil palm? Because FGV and FOB last time they did publish some papers on this. Can you share your thoughts on this? Thank you.
All right. I think Dr. Bazli also know that to edit in the palm is possible. I would say possible, but still on the process. MPOP have published a paper, but the palm, I don't think the palm is planted in the field, but they have successfully edit the genes through tissue culture material. But then what's the uptake or the perception from the community, the Malaysian? Is it GMO? Then GMO, you know, the negative thought about GMO, you already know, because all of us are molecular. And then in plantation as well, we need to comply with several certification, MSO, RSPO, MSPO, RSPO, and then the EU requirement if you want to sell the CPO there. So all these certification don't allow GMO. I know gene editing is so-called as not GMO, right? The definition is still a gray area. But then to be safe, not to go there. But once we like the one that I mentioned in the Ganoderma gene editing, once we use a gene editing as a tool to study which genes, to find genes. That's the way we going to apply the gene editing method.
All right, thank you. So of course, we establish existing work, right, between INBIOSIS and LGB through our fellows here. I think that's it. So on behalf of the organizing committee, I would like to say a big thank you to Dr. Azinuddin. But before we end our session, I would like to share that we have more than 90 participants combined from WebEx and Facebook Live. And also for all the audience and participants, we're going to have a photo session. So please turn on your camera. So I'll have Mrs. Intan, is it, or Dr. Imelda to take the photo? Sorry, Dr. Murni.
And hi, we will have photography session now. Yeah, welcome 1, 2, 3, and smile. Okay, 1, 2, 3, smile. Okay, another one. 1, 2, 3, smile. All right, thank you.
Okay. Again, I would like to say a big thank you to Dr. Azinuddin. Yes, I think you've seen the videos as well from Dr. Azinuddin. They have services at NSTAC, and I think maybe perhaps in Pahang as well. So feel free to contact Dr. Azinuddin for more information on the services. And for all the participants, we're going to display the QR code later, which is only available for 15 minutes. So please stay tuned to get your attendance filled.